You notice we have one missing side of a right triangle. So when we're only missing one side, what do we use to find it? Okay. We can't use that yet because we don't know the angle measure. So we have the angle measure that's possible, but we're going to use that on the back. There? Is that a squared plus b squared equals c squared? When you don't have the angles and you're only missing one side, you use the Pythagorean theorem. What did we say is always our c? The biggest number or the hypotenuse. We know it's the hypotenuse because it's across from the 90-degree angle. Go to your 90, go across. That's always your c. Does it matter which one your a and b are? No, I'm going to say that's my a, that's my b, doesn't matter. And still, in your information, we have 2 squared plus 6 squared equals x squared. And then you solve. What's 2 squared? 4, 6 squared? 36. And what is 4 plus 36? 40. In order to get x by itself, what do we have to do to both sides? Square root. Always checking your calculator. Is 40 a perfect square? You just square root of 40. You get a whole number? Nope. That means we have to simplify it. So we have to break it up into 2 radicals and find the largest perfect square that can go into 40. Well, the very first thing you should do when you get your test tomorrow, second you get it, write those perfect squares at the top of your test. And the list of the first 10 perfect squares, if you don't have them memorized, all you have to do is 1 square, 2 square, 3 square, 4 square in your calculator. Here's the list. If you plan on using your test review, if you write this down, it's already written for you. 36, 49, 64, 81, 100. You have to figure out the largest one that can go into 40. What's the largest perfect square that can divide into 40? 4. How many times can 4 go into 40? 10. So that goes in the other radical. Clean it up. What's the square root of 4? 2. Can we take the square root of 10? So we are done. That missing side is 2 radical 10. Your directions say leave your answers in simplest radical form. That means you have to leave it like that. You have to simplify it. If you just plug in radical 40 and round a decimal, you will lose a point for not simplifying. But yeah, you got a big chunk of the points. You still lose one if you don't simplify. Question. Alright, same thing with these. We said which one always has to be our C. Go to your 90, go across, that's our C. A and B do not matter. Fill in your info. Squared plus B squared equals our C squared. Simplify it. What is 4 squared? 16. What's 10 squared? 10 squared is 100. We want to get x by itself, so what do we have to do with 16? Subtract it. We got to move it over. So get x squared is equal to, what is 100 minus 16? How much is it? 84. Again, what do we have to do to both sides to get x by itself? Square root. Okay? Again, it's 84 perfect square. No, you take it, always check first in your calculator. Square root of that number. If you get a whole number, you're done. That's your answer. When you take the square root of 84, you get a decimal. So we have to simplify it. What's the largest perfect square that can go into 84? 4. How many times? 21. When you go through your list and check, the largest perfect square is 4. It can go in 21 times. What's the square root of 4? 2. Can't take the square root of 21. Always double check to see if it's a perfect square first before you filter. Questions over that?
All right. Let's go on to number C and number D. All right. Roman numerals. 100 and 500. Roman numerals. So let's talk about this. A lot of you guys want to do is what you were doing a second ago. You want to say, all right, let's do this. Let's do all the sides, blah, blah, let's do some trig. What do you do here? Well, I can't do Pythagorean theorem. Can't do it. You know why I can't do Pythagorean theorem? How many sides do I have? Well, I need 2. How many do I have? 1. Can't do that. Good. So then you're thinking, all right, let's do some trig stuff. SOHCAHTOA, right? You guys want to do SOHCAHTOA? And I'm going to say no, because the directions would say leave in simplest radical form. If I do SOHCAHTOA, I'm going to get a decimal of some sort. Don't want that, or a whole number, you could. But most of the time you get a decimal. So what we need to do is, we need to use our special right triangles. So we have 2 special right triangles we learned about, and you have that on your formula sheet. First, determine what formula, or which one it is, determine what side you're given, and solve for the missing piece. So looking at C, what type of special triangle is this? Here's your options. 30, 60, 90, 45, 45, 90. Which one is this? 45, 45, 90, because I know I have 1, then I automatically know this other one is also whatever it is, 45. So 45, 45, 90. Again, on your formula sheet that will give you those orange sheets that I laminated, you guys will have this formula on there. You just have to look and identify how to use it. I know these things are the same. This is a 45, 45. What is that hypotenuse side in a 45, 45, 90? Well, again, it's going to be the hypotenuse, but it's going to be what? It's going to be x times what? Radical 2. All right. There's my diagram I have. You guys will be given that. So looking at my picture, am I given a leg or a hypotenuse? Which one am I given? Aaliyah? Hypotenuse. So that means it's a big piece. How do I go from a big piece to a small piece? Divide. And what do I divide by in a 45, 45, 90? Radical 2. So I'm going to go up here and say, oh, there's my side. It's 16. Divide that by radical 2. Looks pretty good. What's the issue with this? Can't have a radical in the bottom. So what do we do? Real easy shortcut. Aaliyah's on a roll. Yes, go. You could do it that way. Yes. You're exactly right. So you say multiply by radical 2 over radical 2. That would give you 16 radical 2 over radical 4. Radical 4. Radical 4 turns into a 2, so it's 16 over radical 2. So then I divide that out. You could do it that way. Go right ahead. A lot more work. Or, and that way always works. This way works too. But what's the other way to do this, Kat? Exactly right. As you did here, she said, whatever's inside that radical, do that top number divided by that number inside the radical. So what's 16 divided by 2? 8. And then whatever is in the denominator, just tag it on the back of it. So it'd be radical 2. So that is 8 radical 2. So I know this is 8 radical 2. It doesn't ask for it, but what's that other side going to be? 8 radical 2, because you see the legs are exactly the same. They're identical. That's 3, that's 3. If that's a million, that's a million. All right? They're exactly the same. Just remember you have to divide by radical. Again, what type of triangle is it? 45, 45, 90, 36, 90. What piece am I given? Questions on those? Big piece to small piece divide, small to big multiply. Let's look at Number D. What type of triangle is D? 30, 60, 90. Oh, they're already there for you. It's nice. 30, 60, 90. I'm going to draw the diagram, because why not? If you guys have it, I'll give it to you. Right angle, that's x. This is 2 times x. This is x radical 3. Oh, that's 30. Okay, so I'm looking at my diagram, the original picture I have. I ask myself, what piece am I given? Short leg, long leg, or hypotenuse? If it says hypotenuse, I would agree. So that is a big piece. Obviously, that's a larger piece. So I always need to go to a small piece next. How do I go from a big piece to a small piece? Divide. Now, what do I divide by? Well, look where I'm at. I'm on the hypotenuse side. Go to the hypotenuse side over here. What do I divide by on the hypotenuse side? 2. Okay, real easy here. So I'm going to say 36 divided by 2. Get those calculators out. Start calculating away. 36 divided by 2 gives me this number, 18. So I know that this is 18. X is 18. Cool. So now I'm down here on that short leg piece where the X is. So now I have to go to the next piece because I also have to find Y. So I have a small piece. How do I go from a small piece to a large piece? Multiply. What do I multiply by to get that long leg piece? Radical 3. All right, here's calculators again. What's 18 times radical 3? Tricked you. You don't need it. You just do 18 radical 3. So Y is going to be 18 radical 3. Again, we don't want decimals here. We just want to leave it in radical form. So done. Questions with those two? Identify the triangle, identify what piece you're given, and solve for those missing pieces. I feel like we're going to have to do 2 more. Let's do 2 more. Oh, I'm right. I feel like we're going to do 2 more as well. So, number E. What type of triangle is this? 45, 45, 90. There's one, then we know the other one's got to be the same as well. I'm going to draw that triangle again for your reference so you have it. Again, you have it on your little formula sheet. Okay, so what piece am I given? Leg or hypotenuse? Leg. Right there. There it is. All right, so I got one of these pieces right here. Quick, in your calculator. What's x going to be? 8. Because the legs are identical. We know these base angles, an isosceles triangle. The base angles are congruent, isosceles triangle. Then I know those legs, those sides are going to be congruent as well. So real easy, x is 8. No math really needed for that one. Looking down at my picture, I have a small piece. I now need to go to a large piece. So I need to multiply. What do I multiply by in a 45, 45, 90? Radical 2. So again, no need for a calculator here. What is 8 times radical 2? 8 radical 2. Done. Sometimes they're quick like that. You don't need to solve too much. Especially when you're given the short pieces, they're usually pretty easy to solve. All right, number F. Type of triangle. 3069, great call. I'm going to draw that diagram. Why? Because I can. Gift. I was an artist. X. X radical 3. 2x. You're given that. There it is. Enjoy. What piece am I given in this 30, 60, 90? Short leg, long leg, hypotenuse. Long leg. So I get a long leg. Over here, look at my triangle. The long leg side is across from the 60-degree angle. So it's x radical 3. So I always need to go to the short leg next. If I have a big piece, got to go to short leg. If I have a short leg, got to go to a big piece. So I'm going from big to small. I have to divide. What do I divide by on the long leg side? Radical 3. All right. So let's do it. So I'm going to say 8 radical 3 divided by radical 3. 8. Why? What happens? Yeah, they cancel each other out. Radical 3 over radical 3, that's just a 1. 1 times 8 is 8. So easy, y is 8. All right, cool. Cool beans there. So now I know I have my short leg, which is great. I want the short leg. If I start with the short leg, it's awesome. Super easy math there. So I'm down here at this piece. Now I have to find that x, or that hypotenuse side. How do I go from a small piece to a large piece? I have to multiply. What do I multiply by on the hypotenuse side? 2. So right now I'm going to say 8 times 2 gives me this number. 8 times 2 is 16. So x is 16. Found it. Question with those. Those are 4 great examples. I would study those, practice those. You should be fine with that. All right, let's move on to numero dos. We got number 2 here. 25, 65, 60 triangle. Is it a right triangle? Is it a Pythagorean triple? Show why or why not. Okay, cool. Well, first thing first, what should I do to check to see the very first thing? To see if it's a... We could see if there's 60. Now, these are side shapes. We don't know necessarily see the angles. But if we had angles, it's a great way of checking. We can see if it turns in that. If we have an 90-degree angle, we would. What should we check first, though? These are sides. But yes, you're exactly right. He's saying, let's see if it's a triangle first. Pick the 2 smallest sides, add them together. Those 2 small sides better be bigger than the third side. If not, we don't have a triangle. It's just 3 lines that don't touch one another. So, what are the 2 small sides in this example? 25 and 60. Add them together, 85. Is 85 bigger than 65? It better be. Then yes, I have a triangle. We need to see if it's a right triangle. Is there some sort of special formula that we use to work with right triangles? Aaron, what do you think? The Pythagorean theorem. Very good. A squared plus b squared is c squared. Now, there's one rule that has to be true of the Pythagorean theorem. There's one thing that's got to stay the same in every single one you ever do. And what is that one thing that has to stay the same in the Pythagorean theorem? There's something special about one of the sides. Not very confident. What? Hypotenuse? What about that hypotenuse? Something about hypotenuse. He's on the right track. He gave you guys a clue. Oh, now you got air. You're very confident in your answer now. Yes? It's always c squared. What do you know about the actual measure of that side? Jake? It's the biggest. So which one of these sides has to be our c value? 65. Even though it's right in the middle, very tempting to say a squared plus b squared is c squared. So 25a, 65b, 60. C always has to be it. The hypotenuse side, what Jason was saying, has to be the largest. Let's go ahead and set that up. So I'll just say that 25 squared plus 60 squared is equal to 65 squared. Got it wrong there. So get your tabulators out, start tabulating. 25 squared gives me this number. Let's go with this person. Someone different. Why not? Have someone different today. I feel like you said something. I don't know. Ah, David, thanks for raising your hand. Oh, you raised your hand, sir. I can't help it. You broke the golden rule and raised your hand. So 25 squared gives me this. 625. You guys have that memorized. 625. Good. 60 squared gives me this number. Someone different. Someone different. You're the same person you were a second ago. It's not changing. Something. Lauren, thank you. What's 6 squared? 36. Add some zeros on the back. 3,600. Good. All right, this is a tough one. 65 squared gives me this number. Someone from Prospect Hill, perhaps. Champions. Right there, you. 4,225. Prospect Hill way right there. All right, well, let's add these two together. Can someone tell me what's 625 and 3,600? Colby, thanks for raising your hand. What is it? 625 and 3,600. Add them together. Wait, what? So 4,225 is equal to 4,225. Are those equal? Yes, since they're equal, guess what? It is a right triangle. So I can say, yes, it's a right triangle. Nice, right triangle, because both sides are equal on this. Next question. Is this a Pythagorean triple? Is it a P-trig? Some people are saying yes. Some people are saying no. Madison, is it? Why? That's all I need to hear. They're all whole numbers, no decimals, no fractions. So guess what? Yes, it's a P-trig. And I'll put a little quotation. Whole numbers. That's not a hashtag. It's whole numbers. Questions on those? All right. Moving on. Flip that paper 180, please.
For 3, it says use the triangle below to find the geometric ratios. Simplify your answer. So what should you have written at the top of your paper? SoHCATOA, very good. The second you get your test, I would also write this at the top of your paper. So, grab one stuff. No. Okay? So, we want to fill out the ratios for this first one, A. So, we're dealing with angle A. That's the angle you start with. Circle it, put your pencil on it. Here we go. So here's A. You go across. You label that side as our what? Opposite. So if you're 90, go across. You label that as our hypotenuse, and the guy left over is our adjacent. And this is cut off. This is 6. Correct? So then if we're finding sine, how do you set up that ratio? What over what? Sine, it is opposite over hypotenuse. So what did we say our opposite was? What's our hypotenuse? 10. And what must we always do with our fractions? Simplify. What does 6 over 10 simplify down to? 3 over 5. Same thing with B. We have to find the cosine of A. So go to SoHCATOA. Go to cosine. What over what? So the two sides deal with cosine. Call how we set that ratio. If we're doing cosine, how do we set it up? What does the A stand for? Adjacent. What's our adjacent? 8 over, what does the H stand for? What's our hypotenuse? 10. And again, what must we always do with our fractions? Simplify. What does 8 over 10 simplify down to? Anyone? 4. Do the same thing for C. Tangent over TOA, it's what over what? Opposite over adjacent. What's our opposite? 6. What's our adjacent? 8. And what is 6 over 8 reduced down to? 3/4. So that is tangent. For sine of B, what did we say the shortcut was? The sine of one angle is the same as the cosine of the other. So the sine of B would be the same as cosine of A. What did we say the cosine of A was? Cosine of A is 4/5. So that means the sine of B is also going to be 4/5. So without doing any work, you have your answer by just remembering that little shortcut. If you didn't remember that shortcut, what you would have to do is you would go, we're dealing with angle B. Oh boy. So now we're going to circle and start with angle B. You go across from angle B. That's now your opposite. The hypotenuse always stays your hypotenuse, and the adjacent. So pretty much your opposite, your adjacent flip-flop. And then, so we're dealing with sine. Opposite over hypotenuse. Opposite is 8. Hypotenuse is 10. And we said that reduced down to 4 over 5. You just have to relabel everything and redo it all over again. Questions over that? Now we are going to apply this to the next section. And this is already written at the top of your paper. I'm just going to rewrite it. For reference. We're going to use this trig ratio to find the value of x. It says round the nearest tenth for sides and to the nearest degree for angles. That just means the nearest whole number. Okay. So just like we did on the last one. Pull your angle, start at your angle. Go across, Carl, we will label that as our what? Good. Go to your 90, Carl, go across, and we label that as our. Good. And the guy left over, we just say is our. Then look and see. What two sides have information? What pieces do we have? Yeah, the adjacent and the hypotenuse. Adjacent has the number, hypotenuse has your x, so we have the adjacent and the hypotenuse. Which one of these are we going to use? Cosine. So we say cosine of our angle is equal to, how are we going to set that ratio? 10 over x, adjacent over hypotenuse. What's that little saying, Mr. Carr? Oh, to help you remember, x is down low. Row. So the x and the cosine trade places. So these literally trade places. We have x is here, and over the cosine of 72. Then you plug on your calculator, and you have your answer. If you have a graphing calculator, you literally plug it in how it's written. If you're dealing with one of our calculators, you just have to do 10 divided by, then go backwards, 72 cosine enter. We're not going to tell you how to use your calculator tomorrow. So this is your time to practice. And if you have questions over how to use it, this is your time to ask. Whether you have a graphing or one of ours, we're not going to tell you how to use your calculator because we're telling you how to get the answer. So it's your job to know how to do it. And then what do we get? 32.4. Everyone agree? You did not get 32.4. Make sure you're raising your hand so we can help you. Very good. Questions over that one? 5 is very similar. Again, start at your angle. And start here. Again, across of your angle, we label that as our opposite. Cross of your 90s, your hypotenuse. Side left over is your adjacent. Every time. Then look and see what pieces do we have. What two pieces do we have? Yeah, adjacent and opposite. If we have those two pieces, which one are we going to use? Sine, cosine, or tangent? Tangent. Yeah, the O and the A. O and the A, we're going to use tangent. So take the tangent of your angle. How are we going to set up that ratio? X over 22. Opposite over adjacent. Again, what's that little saying Mr. Clark told you? When X is up high, we multiply. So just multiply by 22 on both sides. That way it cancels. Left with X, and you plug it in your calculator exactly how it's written. If you have a graphing, if you have one of ours, you work backwards. So you do 75, then hit 10, then times it by 22. You're going to make sure you are practicing this in your calculator so you know how to do it tomorrow. What do we get? 82.1. Can everyone agree with that? That's what I got. At 82.1. If you did not get 82.1, make sure you're raising your hand and asking. And last one. What's a little bit different about 6? 7? Yeah, the angle is missing. There's a variable there instead. But your process is still exactly the same. It's just how you enter your calculator that's a little different. Okay? So start at that variable, start at your angle, go across, opposite, cross from your 90 to your hypotenuse, left over to your adjacent. So again, look and see, what 2 pieces do we have? What 2 sides have information written on them? Opposite and hypotenuse, so if we have our O and our H, which one are we going to use? Sine. Process is still the same. We take the sine of our angle, we just don't know what that is, so we write an X. Equal to opposite over hypotenuse. What did we say when the angle's missing? It's not a first, we use the inverse. So what you're going to do in your calculator, you have a graphic. You just hit the second button. And then whatever trig function you're using, this case we're using sine, second sine, you get that -1 button, -1. So it's like saying sine to the -1. Then you just type in that fraction. So you do 4 divided by 14. If you have one of our calculators, you have to divide first, then do green button sign. So do 4 divided by 14, green button sign. What do we get? 16.1. It said for 16.6. 16.6. I mean, don't check how close it is. It said go round to the nearest degree. That means whole number, so this would actually be what? 17. Right, so that angle right there is 17 degrees. Questions over that. And very similar ones on your test tomorrow. For 7, it says name 3 Pythagorean triples. So what is the most basic of those Pythagorean triples? 3, 4, 5. If you can just remember 3, 4, 5, you're going to be perfectly fine. Because if you can remember 3, 4, 5, what can we do with those numbers to get another one? It's about the same number. So pick a number, does not matter. Any number. 2. So 3 times 2 is 6. 4 times 2 is 5 times 2 is 10. Repeat it all over again. What's another number we want to multiply them by? 5. 3 times 5. 4 times 5. 4 times 5. 20. And 5 times 5. 25. You can pick any number. You do 100. You do 50. You do 20. You do 3. 4. Does not matter. Pick any number. You can just remember 3, 4, 5. And multiply them all by the same number. Questions over that? Okay. We have time. We're going to go back to 8. Go ahead and flip it over to 9.
All right, number 9. Got some trig. Got a real life example. Let's figure out some stuff here. So we have 2 office buildings that are 100 feet apart from each other. Already marked up there. From the edge of the shorter building, the angle of elevation to the top of the taller building is 28 degrees. Already marked right there. Angle of depression at the bottom is 42. How tall is each building? All right. I'm going to name these towers. I'm going to call this little guy Tower 1. I'm going to call this guy Tower 2. All right. Go ahead and name these towers. Well, I want to figure out how tall Tower 1 is right off the bat. So what we're going to do is we're going to look at a triangle that's matching up Tower 1. So I'm going to be looking at this triangle right here. So that's the triangle that matches up to Tower 1. Cool. Well, I know I have the 100 at the bottom, and I want to find how tall it is. I don't know how tall it is, so I'm going to call that x. That's the height of the building, x. Well, I need an angle or I need another side. I need something else. I don't have an angle. Alexia, yes? It does. It's called angle of depression is 42. So it's looking down to the top of the building. Not only is it the angle of depression, it is also the angle of elevation. Yes, because these are parallel lines, we know the sides. These are alternate interior angles. So whatever this angle is right here, it is also this angle down there. So this is also 42 degrees. Well, now I have all the information I need to solve, at least for the Tower 1 right now. So we're going to do exactly what we did back, up there, back here. Find the start of your angle, label your sides, figure out which one you need to use. So again, I'm going to have that SOHCAHTOA at the top of my page. SOHCAHTOA. Again, we can't tell you that. You don't have that in your formula sheet, so know it. Start at my angle. So starting my angle, there's my angle, 42. Label your sides. What's this side directly across from it? OPP, you know me. Down, across, there's a right angle right here in my triangle. Across from that's going to be my, what's across from the right angle? Hypotenuse. And therefore the last one's going to be adjacent. Always do that one last. So look what size I either have numbers for or a variable. What size do I have numbers or a variable for? What? Leah? Opposite adjacent. Scroll up to your SOHCAHTOA at the top of the page. Which one deals with opposite adjacent? Tangent. All right, tangent does. So I'm going to say tangent of my angle. What's my angle that I started with? It's what I circled, 42. It's why we circle it so we know what we're starting with. Is equal to. Now we do our ratio. Opposite over adjacent. Opposite is x. Adjacent looks like 100. Let that sink in a little bit. Where's x at? Up high, so we need to multiply. So I'm going to multiply both sides by a hundo. A hundo. So really it's going to be 100 times tan 42 is equal to x. And we're rounding it to the nearest foot. So when you type into your borrowed calculator, it's 42 tan times 100. Everybody else, type as you see it. When I do so, round to the nearest foot, and how tall is Tower 1? 90 feet. So Tower 1 is 90 feet. Got it. That's Tower 1. We got to crack the code on Tower 2. But the nice thing is, and kind of look where that dotted line is. See the dotted line going from Tower 1 to Tower 2? Well, I know this is 90 feet. Isn't this section over here also 90 feet? Yes. So really all I can do is just find that upper piece. And then what do I do with those two values? Add them together. So now I'm going to look at a different triangle. I'm going to figure out what that upper piece is. So I'm going to be analyzing this triangle now. Analyzing that one. Okay, let's analyze it here. Well, I'm going to do the same process I've done before. Start with my angle, label my pieces, let's go. So I'm starting with my angle. Now before I do that, notice the distance between the buildings has not changed. So it's 100 at the bottom of the buildings, where that dotted line is, that's also 100 too, if you want to write that in there. I'm also trying to figure out how tall that other section is. So that's my x, that's what I'm trying to figure out. So now, let's go ahead and label. And if you remember this example we've done with the lighthouse and the distance of those boats, if I'm trying to compare similar figures, or not necessarily similar, but figures like this, the setup's usually going to be the same. So watch what happens. Label this side first. It's the OPP. There's a right angle right there. This is my HYP. That means the 100 is going to be the ADJ. It's all in there. What sides do I have value for again? Opposite and adjacent. And usually they stay consistent, guys. The only thing that's going to change, though, is because the 100 is the same, x is the same. What changed between the green triangle and the blue triangle? Just the angle. So the setup's going to be the same because I have opposite adjacent. Again, that's going to be tangent. So tangent on my angle is now 28, is equal to opposite, which happens to be x, over adjacent remains the same as 100. Just like before, x up high, multiply. So it becomes 100 times tan 28 is equal how tall this, equal to x. So how tall is that top of tower 2? Just the top section of it. How tall it is? Marty McFly. 53 feet, she says, and I tend to agree. So this little section is 53 feet. Okay, great. That's from here to there. Well, how tall is that lower section? The other section was 90 feet. So how tall is Tower 2 in total? It is 143 feet. So it's 143. There's how tall my towers are. Question of those, great examples. Again, usually we're comparing figures like this. They're using the same ratios typically. All you do is really change the angle. These are very similar results. Questions on that? Yes, Jason.
If like the tower is like varying widths, would the answer be different?
It would not, because all we're looking at is the height. If you're comparing the width, it would, but we just want to see how tall it is. I don't care how wide it is or anything else. I just want to see the actual height. That's what we're looking at. Good question. Rose?
Remember we are selecting your practice tomorrow.